For the past few months, Stanford Professor Andy Hall ran an experiment that felt both thrilling and vaguely unsettling. Could he automate himself? What does a research institution look like when it operates at 100 times the scale and speed of academia today? To find out, Hall had an AI agent entirely replicate and extend his own complex, months-long study on universal vote by mail. The original paper required a highly trained team, custom data cleaning and stata, and rigorous robustness checks. It cost thousands of dollars and took months. But a single instance of Claude Code, given an autonomous terminal environment, converted the data to Python, corrected its own coding errors, and completed the analysis in under 60 minutes. The total cost? About $10. The price of a sandwich. But the real paradigm shift here isn't just about speed or saving money. It's about a fundamental transformation in the structure of knowledge itself. Currently, academic research is frozen in time. You publish a static PDF, and by the time anyone reads it, the world has moved on. The 100x researcher replaces the static white paper with a living dashboard. Every time new data arrives, the agent detects it, reruns the analysis, and updates the estimates in real time. This leads to what Hall calls structural reproducibility. Instead of trusting a peer reviewer to manually verify the math, the primary output of a study becomes an executable AI agent trace. If the script fails to produce the exact same coefficients, the paper literally cannot be published. It replaces, "Trust me, I did the math," with, "Here is the machine that did the math. Press start." Of course, this approach has notable flaws. These systems still hallucinate, misinterpret nuances in the data, and make careless integration errors. AI models cannot invent a new natural experiment, nor can they perfectly judge which variable matters most for democracy. That still requires profound human verification. Yet, the deep implication remains clear. When the cost of execution drops to zero, the nature of the PhD must change. Young scholars must stop training to be code monkeys and mechanical data cleaners. Instead, they must become architects of inquiry, designing the prompts and parameters that guide these vast agentic swarms.